Hello, everyone, and welcome. My name is Rui. We are going to talk a little bit about developing modern applications using MySQL 8. I'll be pointing to a Node.js use case, but most of the things you will hear about today are not exclusive in any way to any language or platform. I'm the one speaking, but don't be shy. We want to hear from you, so feel free to ask any questions in the Q&A chat at any time because there are experts on standby ready to answer them. Of course, if time allows, we will also answer some of the questions live at the end of the session as well. Just a little bit more about me. I work at the MySQL middleware and clients team at Oracle. I'm the lead developer of the MySQL X DevAPI connector for Node.js. Here's my email address in case you want to reach out, and feel free to do it, of course. So what's in the agenda for today? I'll start talking a bit about the MySQL document store. Then I will move on to show you how you can use the document store in your applications. I'll be doing a small demo as well, and we will close with some takeaways and important pointers. What's this about MySQL document store and how it actually came to be? Should we go relational or should we go NoSQL? This is the question that keeps on popping and keeps everyone awake at night. Well, probably it doesn't, but it's a never-ending debate nonetheless. So much so that there's actually a panel in this event that will try to answer that question. They'll probably fail, but I encourage you to watch it because it will be an interesting panel, I believe. I could go on and list all the benefits and drawbacks of both models, but I think everyone is familiar with most of the arguments by now. On one hand, you have ACID, data integrity, and SQL, the language, which DBAs love. On the other hand, you have things like new data models, faster schema design, sharding, and you don't have SQL, which developers love. However, we probably need both, and I would argue that nowadays we are in a point where all of us, developers or DBAs, can have our cake and eat it as well. And that's where MySQL comes in. How does MySQL approach this whole conundrum? Previously, you had the JSON data type and a bunch of JSON functions since MySQL 5.7, and we've built a few abstractions on top of it. You also had virtual columns, which means you could create indexes and constraints for JSON properties, and you had the usual ACID guarantees provided by the underlying transactional storage engine, InnoDB, of course. Then we started to introduce additional components in the MySQL stack that address other different needs like scalability and high availability, such as the MySQL router and group replication. On top of that, we also released the MySQL shell to manage and tune all this setup even more easily than ever. But the important thing here is that you need to look at the MySQL store as a small part of a bigger MySQL setup, which contains additional components and affects the way that you build your application. So looking at a traditional MySQL application stack, it would go something like this. You have your client application talking to a MySQL database using a SQL base driver and protocol. And nowadays you can have something like this, a more advanced architecture with additional components that address other different concerns. And in this case, these components on the bottom of the side, the X DevAPI, the X protocol, and the X plugin are the ones that actually enable the document store, and we will talk a little bit about them. Starting with the X DevAPI, which is a database API for general purpose programming languages that exposes the document store constructs to the application layer, including things like CRUD operations for NoSQL and relational workloads, a raw SQL interface, and a session abstraction on top of one or more database connections. It's a standard specification that is implemented on multiple clients for different platforms and languages, and it privileges things like query building via fluent methods and non-blocking and asynchronous server communication. One example of an X DevAPI implementation is the MySQL shell, JavaScript, and Python interfaces. The X protocol is a new protocol for talking to the MySQL server, and we believe it is a lot more advanced and easier to work with than the traditional MySQL protocol, the classic MySQL protocol. It's asynchronous and has features like message pipelining and out-of-band notifications. It uses Google protocol buffers for encoding message payload. And it has a stronger security model for things like TLS and authentication, and as things like native variable interpolation at the protocol level, which helps to mitigate a lot of the risks related to SQL injection, for instance, and also has smarter mechanisms for feature detection based on setting expectations instead of sniffing the server version. The X plugin is basically the server-side interface of the X protocol. It's a it's a regular MySQL server plugin and is enabled by default on MySQL 8.0 series. It's also available on MySQL 5.7, but it needs to be manually installed and it lacks a lot of the features that it has on MySQL 8. It also provides its own security, configuration, and monitoring models bounded by but independent from the main server configuration and setup. It operates on a different set of ports, in this case on port 33060 instead of the traditional 3306, so one extra zero. And its main function is to translate X protocol messages encoded by X DevAPI commands into SQL queries that are then processed by the core MySQL engine. And it goes something like this. You start by building a query on your favorite programming language using the X DevAPI. Then the connector encodes it as a protobuf message, which then is encapsulated in an X protocol frame. Of course, protobuf being a binary format, we are using a JSON-like format here just to make it clear and allow you to understand exactly what is being sent to the server. And on the server side, what happens is that the X plugin picks up this message and decodes it and translates it to a regular SQL query that is then handed off to the optimizer. So how does this X DevAPI thing actually work? So to connect to a database, all you need is that a URI that identifies a server or multiple servers. We also allow to define multiple servers with weights basically assigned to them. So you have a URI that identifies that server or a group of servers or a configuration object depending on the programming language you have, and then you just use it to create a connection to that server, or you can create a connection pool with the corresponding additional pool options, and then you can acquire connections from that pool. So it's pretty similar to other alternatives on the market, other database drivers on the market. Documents exist in the scope of collections, and collections exist in the scope of a schema, which is a MySQL namespace for grouping tables, basically. And so the X DevAPI needs to provide methods to manage these schemas and collections as well. So and it provides methods to check if a schema exists in a database or a collection exists in a database, and provides methods to create those schemas and collections, and of course remove those schemas and collections. So this is how you start off with the X DevAPI basically. So we're talking about collections, but what exactly is a collection? So if we create a collection using the X DevAPI, as we've seen before, and we run a show create table query on it, this is what we get. So it's just a table, but in this case it has some special meaning. Notably, it has a JSON column which accommodates the actual documents. And it has a column with an underscore ID, which is a unique identifier that matches to the identifier of the document itself. And in this case, it is just a virtual column which allows them to index these values. We also have, so the document store now supports JSON schema validation. So this means that the documents can only be added to a collection if that document respects the existing JSON schema. By default, it allows any kind of JSON content, but this can be changed and the schema can be updated to a more restrictive definition. And to work with collections, the X DevAPI provides a list of CRUD methods like add, find, modify, and remove, which operate on multiple documents at the same time, basically. And additionally, there are utility methods for retrieving, removing, replacing, or upserting a single document in the collection. With virtual columns, you can create indexes for any property in the document. And working in the scope of an ACID compliant session, we can use transactions, we can also use save points, and we can use read logs as well and apply them to a given set of documents we plan on reading. Looking at these CRUD operations a bit more in detail, adding documents to a collection is fairly straightforward. So you call the add method and provide one JSON document or a list of JSON documents. The API is supposed to be fluent, which means you can call the method as many times as you want with as many arguments as you want, and everything will then be sent to the server only and once you call the execute method. Retrieving documents is also easy, although it looks a little bit more complicated. Most of these things are optional. So you have a bunch of options to tune the query. You can establish optional operational boundaries, such as filtering criteria, define projections, aggregations, sort, limit, and skip results, and create read logs. So these boundaries can be defined using a custom expression syntax, which is similar, but a lot more simpler than SQL. And among other things, these expressions allow you to define placeholders to which we can later assign values using the bind method. And this binding happens at the protocol level and leverages protobuf type safety, which means the risk of SQL injection is close to none in this case. Once again, you are free to build your query in as much steps as you wish, and it will only be sent to the server when the execute method is called. There are various alternative ways to modify a collection. We can replace or remove one or more properties of a document. And if one of those properties is an array, we can insert or delete items from that array. Similarly to collection find, we can also define an update order or limit the number of documents that actually are to be updated, basically. And once again, the execute method ensures that the query is effectively sent to the server. Removing documents from a collection boils down to optionally establishing the filtering criteria. If you don't, it will remove all the documents. And optionally as well, define an order for the operation, a limit for the number of documents to remove, and the other things we have been talking about already. Here are some examples of that expression syntax I mentioned before. Again, it's used mostly for establishing operation boundaries like filtering criteria, order clauses, and projections. And there's this top level EXPR method, which allows you to do other fun things like computed projections, as we see in this example here, where we are projecting an object whose value uses an SQL function, in this case concat, that uses properties from the document that actually exists in the collection. So it's pretty flexible. When you run a query, you get a result instance, which has a contextual API that provides access to information about the operation details, column metadata, and the result set itself. So I'm using generic API signatures here, but for example, in Node.js, the execute method, which effectively sends the message to the server, is asynchronous, and so it doesn't return the result instance. It returns back a promise, which will then eventually resolve to that result instance. In this case, we are adding documents to a collection for which an ID will be auto-generated on the server. And in this case, among other things, we can check how many items were affected by the operation. In this case, only the item that was added, the document that was added, so we get one. And we can retrieve the list of IDs that were actually generated from the server. Once again, only one ID was generated. Alternatively, we can provide our own IDs using an underscore ID property in a document, and the server will not generate those IDs for us in that case. With collections, retrieving data only yields one result set, and we can iterate over it using the fetch one and fetch all methods. Mind that both these methods clean after themselves. So if we call them sequentially, like we are doing in this example, they will not yield the same outcome because the cursor has been entirely consumed by the first call to fetch one, because the collection only contains one document. But this is just for illustrative purposes. So. As we saw before, there are methods to work with a single specific document, and additionally, each property in these documents can have its own index, so the API also provides methods for creating those indexes and removing those indexes as well. You can create, commit, or rollback transactions, and within those transactions you can also use save points, and you can use read locks with additional locking options on one or more documents in the scope of that find operation. So the title mentions Node.js, but up until now we haven't seen anything in any way related or specific to Node.js. So I wanted to do a quick demo to show you how easy it is to get started with the MySQL document store and the X DevAPI with a small Node.js application, basically. So I'll just switch to my text editor. And as you can see here, so this is a regular Node.js package with a package.json file. We have our dependencies listed here. We have the MySQL X DevAPI connector dependency here on version 8.0.21. We are also using an HTTP framework, but it's a bit out of scope of this demo, but we will be building a small HTTP API just to showcase how easy it is to add documents and fetch documents from a collection, basically. So the app is really simple. It has about 65 lines of code, I guess. And it has 3 routes. It has one main route, one main endpoint, which basically lists the schemas available in the database, and it also shows the host name. And then we have here two additional endpoints, which will be we will be writing some code to add functionality for them. One of them will be to create entries in the database, so adding documents to the collection effectively, and the other would be to retrieve those documents from the collection. In this case, we already have a simple database set up, so I'm creating a connection pool here on line 11, and then I'm using that connection pool before the web server starts, the HTTP server starts, to retrieve a connection from the pool, and then I create a collection that will then be used to save our documents and to retrieve our documents. And only then I'm starting the HTTP server, and then I have a lifecycle function here that basically executes every time a response is sent back to the client, which basically closes the the existing connection that we acquired from the pool, so it releases it to the pool, so then when another request comes in, it can pick it up again and reuse it. So if we go to a web browser and we issue a request to the endpoint where the app is running, it's running on localhost port 3000. We can see the details that I mentioned before, the host and the list of schemas. If we navigate to the services endpoint, which should be listing the documents that we have on our collection. In this case, it tells me that the page can't be found because the endpoint still doesn't have any logic. So I'll just add some logic to that endpoint. And what we want is basically we want to issue a find query on the services collection. So we do something like this to retrieve a connection from the pool. And then we can get the collection using the default schema. So I forgot to mention, but I'm using Docker, the MySQL Docker image, which basically allows us to set up a schema once we launch the container, basically. So it already has a default schema that is readable and writable by a user account that we have configured for the application. So we can retrieve that default schema that is also being provided via configuration to the application, and we can retrieve it here. And using that default schema, we can then retrieve the collection that we want, which is called services. And then all we need to do is that we need to, so this is an asynchronous operation, the find in this case. So we need to issue a find on the collection. And then we want to return back whatever the list of documents that we have from that collection. So we need to call the fetch all method. So if I build the app again, and if I go to my browser, my web browser, and if I refresh the page, then I should be getting an empty list and not an error in this case. So as you can see, I get an empty list here. So now we need functionality to actually add those documents to the collection. So it should also be fairly easy. So now we are working with this other endpoint here, which is which will be listening to post requests, to HTTP post requests on the /services path, basically. And once again, we can retrieve a connection from the pool. Once again, the connections will be released from the pool every time a response is sent back to the client with this code here. So we get a session, we retrieve a connection from the pool. We can copy this line here. And now what we want is something like this. We want to call add in the collection. And what we are providing as an argument to add is the payload of the HTTP request itself, which should be a JSON document that will be stored in the collection. So in this case, I can access it via the request.payload property. And then I call execute. And then I can reply back with an HTTP 201 response and tell the client that it can check the list of services on the correct endpoint like this. I'm not coding it like this, but yeah, you get the point, I hope. So now let's rebuild once again. And now we can. So we need to send a post request to add a document to the collection. So we can use curl for that. And I have a file, a JSON file here, which I'll show you in a bit. So I'm sorry. So this JSON file contains an array of services, and these services they're using a specific notation, but it doesn't matter. This is JSON, so we can just pass one of these or all of them to our request, and they will be each JSON object will be saved in the collection. So I'm using this tool called JQ, which basically just fetches the correct service from that file and sends it to my server, my web server or my API server. So as you can see, it returns back a 201 created HTTP response, which was what we were expecting. And if we check this link that it tells us to check, which is the one where we are already on with the browser, and if we refresh this page, we can see the service there. So it added the document to the collection. So this is just to show you how easy it is to get up and running with the document store in the X DevAPI, and in this case in Node.js. Just to finish it off, MySQL has been for quite some time now arguably the most accessible database in the market, and it's even more easier now, I believe, with JSON and the doc store. We also believe it requires a lot less trade-offs than other existing alternatives, because in the end you can use NoSQL for whatever you need without forgoing the effectiveness of SQL, because SQL is always available. There are no arbitrary boundaries, like, for instance, 16 megabyte document size limitations. Well, there is a limit, which I believe it's like 1 gigabyte. But I mean, this is determined by configuration. It's not arbitrary. So what you see is what you define is what you get, basically. One of the advantages of using MySQL is that there's a lot of know-how on the market, and using MySQL for all your data needs can result in simplifying your database installation. So no need to use specific NoSQL data stores and relational data stores. MySQL should be good enough for both. Also, I didn't mention a lot of these things, but the MySQL connectors are smart and can do a lot for you. So they provide things like multi-host connections and automatic failover, autonomous prepared statements, and connection pool lifecycle management, just to mention a few. And these features make these connectors a lot more than your traditional database SQL drivers. So once again, keep in mind that the document store exists in the scope of a plethora of components that define a modern MySQL stack. So everything sits on top of a reliable transactional storage engine, which is InnoDB once again. And you have the MySQL shell, which allows you to import data from other databases and also, of course, export data from MySQL easily. You have things like InnoDB cluster, the MySQL router, and group replication that will provide you with the only scale-out path that you will probably ever need. So what we saw today was just the tip of the iceberg. My colleague Fred goes a bit more into detail about all this in his blog post. In his blog posts, you can check this one in specifically. He mentions the top 10 reasons for doing your NoSQL work with MySQL, and I think it's worth a read for sure. And talking about learning more, here are a few more interesting links. The first one is the landing page for the X DevAPI Node.js connector that we saw working just a moment ago, which is available on NPM. And it's open source, so the source code is available on GitHub as well. If you want to learn more about the X DevAPI, the X protocol, or the X plugin, you can check some of these links. Sometimes we blog about these things, other times we don't, but when we do, it's usually on this website, insidemysql.com, so you should check it out as well. I definitely plan to write a lot more about this in the future. I also encourage you to join our MySQL community Slack, and the instructions to do it are also on my colleague Fred's blog. So you should just check out this last link, and it contains the steps required to register on the MySQL community Slack workspace. And come hang out with us. We are open to feedback. We love to answer your questions. So we will use the remaining time to answer some of your questions, which you have been sending in via Q&A chat. If you haven't already, make sure or feel free to ask them at any time. So I see there are some questions already here. So is JSON a textual or a binary data type? Good question. So JSON is a binary data type, but it still allows for things like partial updates. So when you add a new property to a document, or update an existing property of that document, the whole document is not replaced, only the meaningful diff gets applied, basically. How many X DevAPI implementations exist besides this one for Node.js? Well, I don't know about community-driven projects, but as for Oracle official projects, you have X DevAPI connectors for Python, Java, PHP, .NET, and C++, and of course, you also have the MySQL shell, which is an implementation of the X DevAPI. Can you perform joins using the X DevAPI? Short answer is yes. Long answer is you have to do it using SQL. Again, we haven't talked too much about this, but the X DevAPI contains methods for sending raw SQL statements to the server as well. And since the document is just a JSON column, and you can use JSON functions to manage whatever properties exist on that document, you can easily join those values with values from different columns as well. But right now there is no first class API to do joins. You have to use SQL. What is the minimum version of MySQL that is supported? So right now we ensure full compatibility between clients and servers in the same version. So if you are using X DevAPI and 8.0.21 X DevAPI connector, you are guaranteed compatibility with MySQL Server 8.0.21 as well. For most things, there is a high degree of forwards and backwards compatibility. But I mean, if you want new features, you need to upgrade the server to the version that supports those features. If these features or whatever are backported to a previous version like 5.7, it's also possible to use it, but this happens less and less frequently. So we advise against it, and we recommend everyone to upgrade to the latest and greatest version of MySQL Server and clients, which at this point should be 8.0.21. What is the minimum version of Node.js that is supported? Well, there's nothing that actually binds us to a specific Node.js version, unless we are using new JavaScript syntax or new core Node.js APIs available in most recent Node.js versions. Either we or one of the third-party libraries that we depend on do it. So there's nothing that binds us to a specific version. Right now, you can use, the minimum version you can use is Node.js 4.2. But this can change in the future, and you need to be a bit careful about that, because we don't follow semantic versioning in our release model. So if you blindly upgrade the client, it might result in breaking your application. So Why does the X protocol use Google protobuf instead of something like HTTP and JSON? Well, good question. So HTTP has its own view of authentication, and MySQL has a different view of authentication. And since the X plugin supports things like pluggable authentication mechanisms and stuff like that, HTTP wouldn't work well for that. And with regards to JSON, I mean, JSON is a textual format, protobuf is a binary format, which makes it a lot more faster to serialize and deserialize, and a lot more compact as well. So and it also provides things like this type safety character of protobuf also allows us to do things like the protocol level bindings that I've mentioned a couple of times before. So it's mostly for reasons related to performance and security, I guess.